In today's video, we are going to find the maximum and minimum values of a function or extreme values. In the previous video, we have discussed the maximum and minimum values of a function with the help of a diagram. We have also discussed what are the necessary and sufficient conditions required for the existence of a maximum and minimum values of a function. Let us look at the first problem. They have asked to find the maximum and minimum value of the function y equals 1 by 3x cubed minus 3x squared plus 8x plus 25. In the solution, we will write down, given the function y equals 1 by 3x cubed minus 3x squared plus 8x plus 25. We need to find the maximum and minimum value of the function. Before proceeding further, let us again look at the two conditions that are required for the existence of a maximum and minimum values of a function. The first condition is also known as the necessary condition or first order condition, which requires that the first order derivative should be equal to 0. That is, f prime x or dy by dx should be equal to 0. The first order condition ensures that at the point of maximum or at the point of minimum, the slope of the function should be equal to 0. The second condition is also known as the sufficient condition or second order condition. For the existence of a maximum value, the second order derivative should be negative. That is, f double prime x or d square y by dx square is less than 0. Now this ensures that the graph of the function is concave downward. For the existence of a minimum value, the second order derivative should be positive. That is, f double prime x or d square y by dx square is greater than 0. Now this ensures that the graph of the function is concave upward. Let us now find the first derivative of the function. The first derivative is denoted by f prime x or dy by dx. dy by dx is equal to ddx of y or ddx of 1 by 3x cubed minus 3x squared plus 8x plus 25. Applying the sum and difference rule, the derivative with respect to x of 1 by 3x cubed minus 3x squared plus 8x plus 25 is equal to derivative with respect to x of the first term 1 by 3x cubed minus derivative with respect to x of 3x squared plus derivative with respect to x of 8x plus derivative with respect to x of 25. Using the constant times a function rule, the derivative with respect to x of 1 by 3x cubed is equal to 1 by 3 times the derivative with respect to x of x cubed minus, again using the constant times a function rule, the derivative with respect to x of 3x squared is equal to 3 times the derivative with respect to x of x squared plus, again using the constant times a function rule, the derivative with respect to x of 8x is equal to 8 times the derivative with respect to x of x plus the derivative with respect to x of constant 25 is equal to 0. Using the power function rule, the derivative with respect to x of x cubed is equal to 3 x to the power 3 minus 1, that is x squared minus 3. Using the power function rule, the derivative with respect to x of x squared is equal to 2x plus the derivative with respect to x of x is equal to 1. So we are left with x squared minus 3 times 2x equals 6x plus 8 times 1 equals 8. So this is our first derivative. According to the first order condition or necessary condition, for the existence of a maximum and minimum value of a function, the first derivative or first order derivative of a function should be equal to 0. That is, f prime x or dy by dx should be equal to 0, or in our case x squared minus 6x plus 8 should be equal to 0. In order to find the stationary values of x at which the function is either maximum or minimum, we shall apply the quadratic formula. In the above quadratic equation, the value of a, b and c are a is equal to 1, b is equal to minus 6 and c is equal to 8. Let us now substitute the value of a, b and c in the above quadratic formula. So we have minus the value of b is minus 6 plus minus b square or minus 6 square minus 4 times a, the value of a is 1 times c, the value of c is 8 divided by 2 times the value of a is 1. Minus times minus equals plus, 6 plus minus, minus times minus equals plus, 6 times 6 equals 36 minus 4 times 1 equals 4, 4 times 8 equals 32, 2 times 1 equals 2, 6 plus minus 36 minus 32 equals 4 divided by 2. Square root of 4 is 2. So x is either equal to 6 plus 2 divided by 2 or 6 minus 2 divided by 2. 6 plus 2 equals 8. 6 minus 2 equals 4. 8 divided by 2 is equal to 4. 4 divided by 2 is equal to 2. Therefore, the stationary points at which the function is either maximum or minimum are at x is equal to 4 and x is equal to 2. So we have found the stationary points, that is the values of x at which the function is either maximum or minimum. We have completed the first order condition. In order to find the maximum and minimum value of a function, we need to satisfy the second order condition. In order to satisfy the second order condition, we need to find the second derivative. Let us now proceed to find the second derivative of the function. The second derivative of a function is denoted either by f double prime x or d square y by dx square, which is equal to derivative with respect to x of the first derivative, that is ddx of dy by dx. The first derivative of the function dy by dx is equal to x square minus 6x plus 8. So in place of dy by dx, we will write down x square minus 6x plus 8. Applying the sum and difference rule, the derivative with respect to x of x square minus 6x plus 8 is equal to derivative with respect to x of the first term minus derivative with respect to x of the second term plus derivative with respect to x of the third term. Applying the power function rule, the derivative with respect to x of x square is equal to 2x. Minus, applying the constant times a function rule, the derivative with respect to x of 6x is equal to 6 times the derivative with respect to x of x plus the derivative with respect to x of constant 8 is equal to 0. 2x minus 6, the derivative with respect to x of x is equal to 1. 6 times 1 equals 6. According to the second order condition, if at a certain value of x, the second order derivative is negative or it is less than 0, then it ensures that the function has a concave downward graph and yields a maximum value. Similarly, according to the second order condition, if at a certain value of x, the second order derivative is positive or it is greater than 0, then it ensures that the function has a concave upward graph and yields a minimum value. In order to know whether the second order derivative is positive or negative, we need to substitute the values of x equals 4 and 2. Let us first substitute the value of x equals 4. 2 times 4 equals 8 minus 6. 8 minus 6 equals 2. Therefore, the second order derivative is positive at x equals 4. Let us now check whether the second order derivative is positive or negative at x equals 2. 2 times 2 equals 4 minus 6. 4 minus 6 equals minus 2. Therefore, at x equals 2, the second order derivative is negative. So we can write down, hence the function y equals 1 by 3x cubed minus 3x square plus 8x plus 25 is minimum at x equals 4 and maximum at x equals 2. So we have completed both the first and second order conditions. Let us now find the minimum and maximum value of the function. In order to find the minimum value of the function, we need to substitute the value of x at which the function is minimum. So the function is minimum at x equals 4. Let us now substitute the value of x equals 4 in the function y equals 1 by 3 x cubed minus 3x squared plus 8x plus 25. So in each term, wherever x is present, we are going to substitute it by 4. By doing so, we have 1 by 3 times 4 to the power 3 minus 3 times 4 to the power 2 plus 8 times 4 plus 25. 4 cube is equal to 64 minus 3. 4 square is equal to 16 plus 8 times 4 equals 32 plus 25. 1 times 64 equals 64 minus 3 times 16 equals 48. 32 plus 25 equals 57. 57 minus 48 equals 9. 64 by 3 plus 9 equals 91 by 3. 91 divided by 3 equals 30.33. Let us now find the maximum value of the function. In order to find the maximum value of the function, we need to substitute the value of x at which the function is maximum. So the function is maximum at x equals 2. Let us now substitute the value of x equals 2 in each term wherever x is present. By doing so, we have 1 by 3 times 2 to the power 3 minus 3 times 2 to the power 2 plus 8 times 2 plus 25. 1 by 3 times 2 to the power 3 is equal to 8 minus 3 times 2 to the power 2 is equal to 4 plus 8 times 2 equals 16 plus 25. 1 times 8 equals 8 minus 3 times 4 equals 12 plus 16 plus 25 equals 41. 41 minus 12 equals 29. 8 by 3 plus 29 equals 95 by 3. 95 divided by 3 is equal to 31.67. So the maximum value of the function is 31.67. Therefore, we can write down the function y equals 1 by 3x cubed minus 3x squared plus 8x plus 25 has a minimum value of y min is equal to 30.33 and a maximum value of y max equals 31.67. Let us plot the function y equals 1 by 3x cubed minus 3x squared plus 8x plus 25 on a graph. Let us input the function. After plotting the function on a graph, we can see that the maximum value of the function is equal to 31.667, which occurs at x is equal to 2, and the minimum value of the function is equal to 30.333, which occurs at x is equal to 4. Let us now look at the second problem. They have asked to show that the curve y equals x plus 1 by x has one maxima and one minima value. In the solution, we will write down, given the curve y equals x plus 1 by x, we need to show that the curve has one maxima and one minima value. Let us find the first derivative of the function. dy by dx is equal to ddx of x plus 1 by x. Applying the sum and difference rule, we have derivative with respect to x of x plus 1 by x is equal to derivative with respect to x of the first term plus derivative with respect to x of the second term. The derivative with respect to x of x is equal to 1 plus, by using the rules of exponent, 1 by x can also be written as x to the power minus 1. By applying the power function rule, the derivative with respect to x of x to the power minus 1 is equal to minus 1 x to the power minus 2. Plus times minus equals minus x to the power minus 2 according to the first order condition for the existence of a maxima or minima value of a function, the first derivative should be equal to 0, or 1 minus x to the power minus 2 should be equal to 0. By using the rules of exponent, x to the power minus 2 can also be written as 1 by x square. By transferring minus 1 by x square to the right hand side, we have 1 is equal to 1 by x square. By cross multiplication, we have x square is equal to 1. By transferring power 2 to the right hand side, we have x is equal to plus minus of root 1. Square root of 1 is equal to 1. So x is either equal to positive 1 or negative 1. Therefore, the stationary points at which the function is either maximum or minimum are at x equals 1 and x equals minus 1. Let us now find the second derivative of the function. The second derivative of the function is denoted by d square y by dx square, which is equal to d dx of dy by dx. That is derivative with respect to x of the first derivative of the function. The first derivative of the function is equal to 1 minus x to the power minus 2. So d square y by dx square is equal to d dx of 1 minus x to the power minus 2. Applying the sum and difference rule, the derivative with respect to x of 1 minus x to the power minus 2 is equal to derivative with respect to x of the first term minus derivative with respect to x of the second term. The derivative with respect to x of constant 1 is equal to 0 minus, applying the power function rule, the derivative with respect to x of x to the power minus 2 is equal to minus 2 x to the power minus 3. Minus times minus equals plus 2 x to the power minus 3. By using the rules of exponent, x to the power minus 3 can also be written as 1 by x to the power 3. 2 times 1 equals 2. So the second derivative is equal to 2 by x to the power 3. According to the second order condition, at certain value of x, if the second derivative of the function is greater than 0, that is, it is positive, then it ensures that the function has a concave upward graph and has a minimum value. Similarly, if at certain value of x, the second derivative of the function is less than 0, that is, it is negative, then it ensures that the function has a concave downward graph and it has a maximum value. In order to know whether the second derivative has a positive value or a negative value, we need to evaluate the second derivative at x is equal to 1 and x is equal to minus 1. In place of x, we shall substitute it with 1. 1 raised to the power 3 is equal to 1. 2 divided by 1 equals 2, which is greater than 0. So the second derivative is positive at x equals 1. Let us now evaluate the second derivative at x equals minus 1. In place of x, we shall substitute it with minus 1. Minus raised to the power 3 is equal to minus 1 raised to the power 3 equals 1. Minus 2 divided by 1 equals 2, which is less than 0. So the second derivative is negative at x equals minus 1. Hence the function y equals x plus 1 by x is maximum at x equals minus 1 and minimum at x equals 1. Let us now find the maxima and minima value of the function. In order to find the maxima value of the function, we need to substitute the value of x at which the function is maximum. So the function is maximum at x equals minus 1. So in each term where x is present, we shall substitute it with minus 1. So minus 1 plus 1 by minus 1. Plus times minus equals minus. 1 divided by 1 equals 1. Minus 1 minus 1 is equal to minus 2. So the maximum value of the function is equal to minus 2. In order to find the minima value of the function, we need to substitute the value of x at which the function is minimum. So the function is minimum at x equals 1. So in each term, wherever x is present, we shall substitute it by 1. 1 plus 1 by 1. So the minimum value of the function is equal to 2. Therefore, the function y equals x plus 1 by x has a maxima value of y max equals minus 2 and a minima value of y min equals 2. Let us plot the curve y equals x plus 1 by x on a graph. Let us input the function y equals x plus 1 by x. After plotting the function on a graph, we see that the function has a minimum value of 2 at x is equal to 1 and the function has a maximum value of minus 2 at x is equal to minus 1. At a point of minimum, the slope of the curve is constant, which indicate that the first derivative is equal to 0, and it is concave upward, which indicate that the second derivative is greater than 0 or it is positive. At a point of maximum, the slope of the curve is constant, which indicate that the first derivative is equal to 0, and it is concave downward, which indicate that the second derivative is less than 0 or it is negative.